All right. A rocket launch is being filmed from ground level at a distance of 3,000 feet from the launch pad. The rocket is rising at a rate of 880 feet per second when it is 4,000 feet up in the air. Okay. Part A, how fast is the distance between the camera and the rocket changing at that moment? All right, so let's diagram this out. So basically, we have a camera over here. We have a launch pad over here. And then above the launch pad is a rocket. All right, and that rocket is going up, okay? So if I draw this triangle in here, I'm going to have a right triangle again, okay? I know that the distance right here, the distance between the camera and the launch pad is 3,000 feet. All right. I know that this distance is going to be 4,000 feet, but it's changing, so I'm going to give that a variable. Let's go ahead and use x and y again. So let's do x equals the 3,000, and we'll do y equals 4,000. But we also know that that's changing, so that's dy dt, at a rate of 880 feet per second. Okay. So the question, what are we being asked to figure out? How fast is the distance between the camera and the rocket changing at that moment? So that's asking, how fast is this distance changing? All right. So I'm going to call that h for hypotenuse. You can call it whatever you want. Okay. If you want to do x, y, r, you can do that. All right. So this is another Pythagorean theorem problem. So I'm going to again have x squared plus y squared equals h squared. And the fixed value is the 3,000 for x, so I can plug that in right away. So I'm just going to write that that's 3,000 squared. I'm not going to bother figuring out what that is because I know when I do its derivative, I know it's going to zero out because it's a constant. And let's see if we can figure out how fast this is changing, which means I'm looking for dh dt is my unknown in this particular problem. Okay. So derivative time, the derivative of this, the derivative of 3,000 squared is going to be 0. Derivative of y squared is 2y dy dt. And the derivative of h squared is 2h dh dt. We know from previous problems that we can go ahead and we can get rid of those 2's if we want, and that 0 is also irrelevant. And we can start plugging in the numbers that we know. So we know that y is going to be 4,000 feet at that particular moment in time. We know the rate for dy dt is 880 feet per second. And that's going to bother me. Not balanced. Hold on. And then h we don't know, and dh dt we don't know. So those are going to be the two things that we need to figure out. But similar to all of our other related rates, I can figure out what the hypotenuse is at that particular moment in time. I can use Pythagorean theorem, or I can recognize, hey, look at this. I've got 3, 4. This is going to have to be a 5. This is a 3, 4, 5 triangle, okay? So I can exploit the fact that this is a 3, 4, 5 triangle to avoid the Pythagorean theorem if I want to. So this is now going to be 4,000. Actually, let's figure out what this number is, Miss Mara. 4,000 times 880. Excuse you. There we go. 4,000. Calculator time. 4,000 times 880 is 352 and then 4 zeros. And then the h is going to be 5,000. And then we're going to have dh dt, which is what we're solving for. All right, divide out that 5,000, and you're going to get a nice, pretty answer of dh dt is equal to 704. 704, that'll be feet per second. Okay, so that is the final answer. There's no rounding involved on this one, which is a happy little coincidence, but doesn't happen very often. All right, so it's another Pythagorean theorem problem. Now there's a follow-up to this that I want you to see in the next video. All right.